6/4. Oh, that's not good. All right, here we go. We are going to talk about today rational exponents. Do you already know what that is? They're exponents that are fractions now. So we've had exponents that have been positive, they've been negative, but we've never had fractions before. No, it's super fun. Okay, here we go. We have 3 parts today, and it's not too bad, it's not too long. And we also have a review worksheet to do. So letter A, it says here, instead of writing a radical expression, we're going to use exponents instead. So we're going to take our radicals that we've been doing, like our square roots, our cube roots, stuff like that, and we're going to write these in exponential form. We're going to write them as exponents. Okay. It's not too bad, okay? So let me show you a quick example of how this works. If you had the square root of 25, now we all know that's equal to 5 and yada, yada, yada. But what our goal is to do is to rewrite this in its exponential form, because you can write this as an exponent instead. Now, what's the index of this radical? 2. You remember what index was? Index is the little number that sits in there, okay? Square root of 25 can be rewritten as 25 to the 1/2. That's what that means. Okay. So knowing that, yeah, you would. But what if there's a variable? So what about the cube root of x? And we wanted to write that in exponential form. Like, you don't know how to do this yet, but what do you think it is? Take a guess, just based on that last one. X to the 1/3. Perfect. X to the 1/3. Okay?
So you pretty much put a 1 on top of every.
Well, that's the thing. If you have something like this, cube root of x squared. Okay? 2/3. Yeah. Okay, so this would be x is squared. It's the power is raised to is 2, but because its root is a cube root, it would be x to the 2/3. So the top number is going to be the power, and the bottom number is the root. When you think about roots of a tree, they go underneath into the ground. The power's up top. Okay? There's all kinds of things we're going to do. You're so thinking ahead. That's adorable. Here we go. Let's do one. So number 1. We're going to simplify, and we're just going to start basically with some basic easy ones that are just numbers, okay? So let's simplify. Here we go. We have 125 to the 1/3. Now some people, they don't like fractions, right? Are you a non-fraction lover? I like fractions. They're okay. But what I'm used to is instead of writing this as to the 1/3, this is the same thing as the cube root of 125. And the cube root of 125 is 5. So 125 to the 1/3 is equal to 5. Okay?
You don't put the exponent?
No, we already did it. Yep. 5 to the 1? 5 to the 1 is just 5, yeah. So if you had something like this, 5 to the 1/2 times 5 to the 1/2. There's 2 ways to look at this problem. One way is you can rewrite those as their radicals from their exponents. So that would be the square root of 5 times the square root of 5, which is
25.
square root of 25, which is 5. Perfect. Or you can use your exponent rules. What's this rule? If I have something to a power and that same base to a power, what do I do to those exponents? You add them. What's 1/2 plus another half? Same thing. You get the same answer either way you look at it. Isn't that cool? Don't say sure. I hate that word. 5 what? Oh, 5 to the 1 is 5. Yeah, we just don't usually write the 1 to the first power. It's just, yeah, the 0 is 1. Yeah. Okay. How about this one? 10 to the 1/3 times 100 to the 1/3. Now, see here, you can't take those and add them up because they're not the same base. Okay, you can't do anything to the exponents. What we can do is rewrite them in their radical form, which is what we're used to. So this is the cube root of 10 times the cube root of 100. And since they're both cube roots, we can go ahead and multiply them together. And when you multiply these together, you get the cube root of, did you say it? 1,000? And what is the cube root of 1,000? It's 10. Okay? All right, so you're kind of bored. I'm insulting you by how easy this is. Let's get to some harder ones. Letter B.
How many letters do we have?
3 letters, A, B, and C.
How about D?
All right, so we're going to do some more fractions. And this time, we already kind of talked about it with that 2/3 up there. We're going to have numbers up top of the fraction and numbers in the denominator of the fraction. So here we go. If you have, for example, 25 to the 3/2, okay? This would be the same thing. To write this, you could write it 2 ways. You can write this as the square root of 25 cubed. Okay, the bottom number, remember roots are on the bottom, powers are on top. Think about it. If you're pretty powerful, you're on top, right? You're like the power guy, top of the chain. If you're a root, you're underneath the ground. Okay, so powers are on top, roots are on the bottom. Or we can also write this as the square root of 25 cubed. See, they're different. This is 25 to the 3rd power, which is going to be a big number, and then you take the square root of it. Or you can take the square root of 25 and then cube it. It doesn't matter what order it's in. Okay? Watch, I'll even show you. What is 25 to the 3rd power? It's a huge number. It's 15,625. And then take the square root. What is that? And then take the square root of that number, which would be 125. Or a better way, which you don't even need your calculator, is to take the square root of 25 is what?
5.
And 5 to the 3rd is? Oh, isn't that so much better? 2 ways to do it, okay? Either way's right. It doesn't matter. All right, so what they're saying here is there's this property, I guess they call it. If you have any number to the 1 over n, you can rewrite this as the nth root of a. So that's what we did up top. So then, if you have any real number to the m over n, you can rewrite this as the nth root of a to the m, or the nth root of a, all of that to the m. Okay? So this is like the key thing for today. That's what you need to know. And we're going to do some problems now, more problems that involve that. Okay? So I've got 2 of these coming up that involve this thing, and then we're going to do some simplifying at the very end. All right, so here we go. Number, what are we on, 2? Number 2. We're going to rewrite in radical form. We want the radical form for all of these coming up. And these aren't hard, okay? Well, there's one that's kind of hard. Here we go. X to the 3/5. I want you, and me, I guess, I'll do it too. I want us to rewrite this so that it's in, instead of exponential form, because it's written as exponents, I want it in its radical form. So how would we write this in its radical form? There's actually 2 answers. What do you got?
X to the 3rd.
Okay, so the 5th root of x to the 3rd. Perfectly fine. That's it. That's all you need to do. 5 is the root, 3 is the power. Okay? Cool. All right, try another one. Another one. How about y to the 3.5? Now, instead of decimals, we don't like decimals, we're doing fractions. We can write 3.5 as a fraction. 3.5, let's write it as an improper fraction. 7/2? Okay, if we don't know that, you guys, you can do that on your calculator. Do this. 3.5 math fraction 7/2. Okay? If you're struggling with that, it's all right. All right, now let's rewrite this in its exponential form. So this would be, what's the root? 2, the square root, which you don't need to write the 2 in there. And then y to the 7th. And that's all they want you to do. Just leave it like that. Okay? All right, let's do one more of these, and then we'll move on to going the other direction. How about if we had a negative? W to the negative 2/3. Okay? That might bother some of you, the negative there. But you know what? You know what to do with negative exponents. Okay? It doesn't matter if they're fractions or not fractions. What do we do with negative exponents? We drop them down, don't we?
Yep.
We drop them to the bottom and make them positive, make them happy. Cube root W squared. Perfect. Okay? So negatives just get dropped down just like our regular properties for exponential rules. Okay. Now let's do number 3, and we're going to go the other direction. The other direction, we're going to have these written as radicals, and we want to rewrite them in their exponential form. We want to write with exponents, okay? We'll do 3 of those. Here we go. Letter A. So let's do the square root of a to the 3rd. Just so that we know, we can go back and forth between their exponent way to write it and their radical way to write it. This would be in its exponential form, a to the what? Anybody know? Leave it as a fraction. A to the 3/2. 3 is the power. That goes up top. And the root down here is a 2. And so that goes to there. All right, you try this one. You try this one without my help. Let's do the 5th root of b squared. The 5th root of b squared. Think about where the power goes and where the root goes. Okay? And think about fractions. You got it already? Perfect. Anybody else get that? B to the what? 2/5. 2 is the power. Everything's being raised to the 2nd power. And the index, or the root, is 5. Same. All right. So now let's move on. Let's do part C. We are 2/3 of the way done. This is kind of an easier lesson today, too. Well, it's going to get a little harder now. Okay. We're going to simplify. We're going to put it all together and do some tricky stuff. Here we go. Let's start you off with some easy ones, and they're going to get exponentially to more difficult. Number 4. Letter A. We're going to do 32 to the 3/5. 32 to the 3/5. Okay, we need to evaluate this. We need to simplify it. This is actually a nice number, 32 to the 3/5. It is. Okay, what we're going to do is we're going to take the 5th root of 32, and we're going to take that number and we're going to cube it. Okay, you can cube the number first and then take the 5th root, but then they're getting really big. You don't want to do that. So do you know what the 5th root of 32 is? It is. It's positive 2. And then cube the 2. So your answer is 8. Okay, it's like a 2-step problem. You're doing 2 things. You're taking its root, and then you're raising it to a power. You want to try another one? Yes. Yep. I thought so. Let's do 27 to the 2/3. You try that one without my help, without talking to anyone. You try that one. Okay, 2 steps here. You're going to take the cube root of 27, and you're going to get that answer, and you're going to square it. So what'd you get? 9. Me too. The cube root of 27 is 3, and 3 squared is 9. If you can do those in your head, I am so proud of you. Do it in your head. You don't need to show any work. You can do those. You can take cube root of 27 is 3, 3 squared is 9. Done. Did you see that? You don't want to get in there, but you saw it. Okay, here we go. C. Would you want to be invisible or be able to read people's minds? I don't want to know what you people think about me. I would not choose that ever. Okay. No, I would choose none. All right. 4 to the negative 2.5. Ew, it's grody. All right, negative 2.5 or negative 5/2. So we'll change this to 4 to the negative 5/2. 5/2. And then we can rewrite this as 1 over 4 to the 5 halves. See all these steps here? You got to change it from a decimal to a fraction, change it from negative exponent to positive, and now do it. What is the square root of 4? Sorry, to the 5th power. Do you know what 2 to the 5th is? It's 32. Hey, Peter. Thanks. You're on video. All right. Olivia, grad check. Bring iPad. Oh, okay. Sorry, I read your notes. All right, so now I'm going to do number 5. We're going to simplify again, but now I'm going to put some variables in the mix, okay? So variables you can't do on your calculator. So the numbers you can figure out a way to do that, but the variables you can't. So here we go. Let's simplify. 16y to the 8th power, and all of that is going to be raised to the 3/4. Okay. These are going to be interesting. Here we go. Yes, you do. All right, do you remember last Monday, the first day we met? That was fun. We learned our properties of exponents, which say that if you have two things in here and they're both to that power, you're going to put both of them to the power, okay? So we get 16 is raised to the 3/4. And y is to the what? Do you remember when it's a power raised up to a power, what do you do to those numbers? You multiply them. You multiply them. What is that? Is it 6?
Yes.
It is. Ooh, you got that so quickly. All right, so you're doing 8 times 3/4. If you need to use your calculator, that's okay. You can do these in your head, though. Watch. 4 goes into 8 how many times? 2. 2 times 3 is 6. Or, if you don't like that, let's say you don't like that, you can do 8 times 3 is 24, divided by 4 is still 6. If you don't like that, use your calculator. Okay, now, we have to fix 16 to the 3/4. He's snoozing again, I know. That's okay. Yeah, I know. All right, what is what is 16 to the 3/4? Well, it's the 4th root of 16 and then cubed. What's the 4th root of 16? What times what times what times what is 16? 2. And 2 cubed is 8. So your answer would be 8y to the 6th. All right, let's do some more. B. Let's try this one. 8x to the 15th, all of that to the negative 1/3. Okay, I'm going to throw some negatives in. We're going to get some fractions. We're going to get all kinds of things. Super exciting. All right, so do the same thing you did in the last one. Okay, it's a lot like the last one. Distribute that. 8 to the negative 1/3. X to the negative 5. Good. So it's 15 times negative 1/3 is negative 5. And now they're both so sad. So let's drop them both down. This becomes the cube root, or 8 to the 1/3. And what is the cube root of 8? 2. Ew, that was gross.
That's a nice
2. And then this becomes x to the positive 5, and that would be your answer. So your answers are done when all the exponents have all been distributed, no negative exponents, all that stuff. What happened? We're okay? All right, let's do some more. How about, 64 x to the 4th to the 2/3. All right, you try this one, okay? This is a lot like the last two. It's a lot like the last two. You try it, though, on your own, okay? No, that's not good. Why is there a 4? Oh, okay, yeah, it's fine. We can leave it like that. All right, you try this one. Here we go. We have 64 is raised to the 2/3. Oops, 2/3. And x is to the 8/3. Now, I know that didn't turn out nice, so you just leave it, okay? So 64 to the 2/3. You're going to take the cube root of 64 first. And what is the cube root of 64? Oh, 4 times 2/3 is 4 times 2 over 3. It's 4, and 4 squared is 16. So this would have been your complete answer. I know it doesn't look right or feel right, but that's the way it goes. I know, right? Okay, I've got one last one for you.
Is that like the last one?
Uh-huh. There's 3 of them, though. Simplify again, and these are going to be a little different than the last ones we did. Here we go. Letter A. Let's say you have x to the 2/3 over y to the 1/4, and all of this is raised to the 12th power. It looks gross, right? All these fractions and within fractions and x's and y's. Okay, so let's take our power rule, which says when you raise something to the 12th power, you're going to multiply the exponents. So what is 2/3 times 12? So how many of you guys, you're just going to use your calculator on that, and that's fine. I'm fine with that. How many of you guys can do 2/3 times 12, and you go 3 goes into 12, 4 times 2 is 8? Anybody do it that way? Good. A couple of you do it that way. And then some of you do 2 times 12 is 24 divided by 3 is 8. Either way, all 3 ways that you can do it, you will get x to the 8th. All right, on the bottom, we get y to the 3. And then that's it. They're not like terms. There's nothing else to do. That's it. It looked so bad, didn't it? And it wasn't. Yeah, that's all you do. Okay, let's do a bad one now. Let's do 36 x to the -8 over y to the 4th, and all of this is to the 1/2.
No.
Yes. Yes, this is a good one. Okay, did you see there's 3 things here? We have a 36, we have an x to the -8th, and we have a y to the 4th. And they're all going to be raised to the 1/2 power. So let's do it. Let's do them all separately. 36 to the 1/2 is? It's 6. Remember what 36 to the 1/2 is? Okay? Yeah, 36 to the 1/2 is the square root of 36, which is 6. Yep. I know you have to square it. Numbers work differently than exponents. That's a number. That's 36. The exponents have their own rules that they follow. Okay? Now, let's go ahead. What is -8 times 1/2? X to the -4, and then y would be squared. Now, all you have to do is fix one little thing.
Wait.
Yeah? What did I do?
Put the x or the exponents to the phone.
Yes, 6 is fine. It has no negative exponents. It's fine where it's at. Move the x to the 4th to the bottom, and then everybody's all happy and good. That's it.